This is my video number 37 on computer technology. I want to look at a new design. We need to rethink our computer technology. So I want to distinguish a vocabulary here. I talk in these terms, and yet I don't think people realize what I'm saying. We have the term application. So when we write software, we write applications. And when we really think about it, what it is a specific use of information. The application only does videos. This one only edits images. And those are applications. The second term that I like to use is technology, which is all possible uses for a data structure. I'm trying to explain why we need to get to a change in our software or our computer design. Instead of building applications, we should be building technologies. We have no technologies in our current systems. They are simply billions of applications. We need one technology. So like I said, we have in our current system, we have billions of isolated applications and no technologies. So all of our computer hardware devices are unique. They are, even our hardware, our CPU is unique and very specific. It only does hardware instructions in one way. So even though there's probably a couple billion ways we could do hardware instructions, the hardware is designed only to do it in one way. And then we, as software developers, are forced into having to use that method of design. And so all of our software applications are fixed. We write them, we can't change them. We are forced to use the conventions that have been set before. We have no consistencies in any of them. All our value types are specific. Our integers, our reals, our time, our date, they're all fixed for us. And they're a particular application, only one method that we're allowed to use. And all of our organization is isolated, means that every application that builds any type of organization for their particular information structures is unique. And each application has to come up with their own way to do this. And then all of our binary values are specific. Means that it's not a technology, this is the way numbers are going to be represented. This is how number of bits that you can represent. So if we look at the mechanical base technology, exactly what that is, kind of get us into the mode of looking at what technologies do exist and what we consider their base technology. So for mechanical devices, we have the lever, the inclined plane, the wedge, the screw, the pulley, and the wheel and axle. And these are the 6 or 7, depending on how you want to break it up, base technologies. And so any mechanical device uses these 6 base technologies. These are not we don't build one lever for every mechanical device. The lever is a particular concept of how to apply force. Same with the inclined plane and the wedge. They each have their own unique capabilities. They do not cross. Nobody tries to come up, there are no other mechanical device that we've come up with. If we did, we could easily. So we have applications using these machine-based technologies. So we have a bicycle that uses the lever and the pulley and the wheel. And then the car, which uses different types of steering mechanisms and the wheel and the axle and everything. And washing machines, gears and things, screws. So these are the applications of the base technology. But for a technology to thrive means that we need to understand what our base technology is, specify it, and then allow it to be used in all applications. Right now, each application has to come up with their own way or use a particular way, when in actuality, so to perfect, we really need in software and computer technology, we need to perfect the base technology. And with this, we would get consistency so that all applications are not worried about the base technology. They go ahead and use it. And everybody understands that this is the only thing, this is the way we can accomplish our computer technology. And availability. Once we build the base technology, then the availability of it is open to all applications. And here we can get progress. Right now we're spending all our time trying to figure out how to count characters and to add and loop through and determine variations of the same thing. But if we can do a base technology, then all of this will be done for us. So our software-based technology, what should it? For one, should be the integer. Should be our base technology. We should not have one integer. We should have all representations possible now and in the future that an integer can represent. So you could have base 2 like we have now, or 3 or 4 or 5 or 8 or 10 or 12 or any base number if we wanted. We could have an offset. We could have any number of bits, so it could be either fixed or variable length integer, so we could represent any integer that we could possibly come up with. So it's not just a base 64-bit. We could have a 10,000-bit integer. Everything in a computer, our whole technology of computers is the bit, is a switch. And we combine those. So our real base, our base technology, unfortunately, is a switch. But we need to move a little further than that. And that's basically where we're at now. That our whole base technology is a switch, and we have to program from that. But if we at least get a base technology, which means all variations of an integer for whatever purpose anybody would want to be able to use. Unlike, similar to the lever, we know what it is. We don't say we have one lever. We just use that term to represent all levers. And here I'm saying the same thing with integers. We say integer, but what we really mean is all digital representations that anybody could come up with for any purpose. Right now, we're being forced into a one structure, very specific application of an integer. And then our second base technology should be move. We need to move values one location to another, whether it's a bit or a billion bits. It's a move. And this is our base technology. And each application has to come up with their own way to move their own information around. And then the value. All of our different values that we think of as being unique, they're not unique. We just need to be able to represent them and have this base technology done for us. So in a value would be like a date and a time and a URL, an address, email, and a mailing address, and billions of other values that we would want to represent. And we want that to be done as our base technology. Unfortunately, right now these are applications. They are not a technology. Any use of any value, any movement of any information and any integer representation become technologies. So right now the integers are hardware specific. Fixed number of bits. Love to go to variable length. Have any number of bits. Here we have 8, 16, 32, 64, 128, and that's about it, which is very limited. And we're all using base 2, we could, it should be all variations, and that would be a technology. And the move is hardware specific. Moving register to memory, memory, register to register, machine to machine, task to task, process to process, thread to thread, and a billion other variations of the move should be a technology. And then our values, so that we can create the basic integers, floating, text, characters. Basically, we don't really have All we really have right now are numbers. And then we represent everything as a number of one kind. And the numbers are really not numbers, they're just a set of bits that we have assigned as being specific numbers. But for software to improve, we need to create a number technology for all possible numbers, all possible representations. We create a movement technology, all possible values being moved in all possible locations. And then create a value technology, so all possible value representations, real fractions, dates, times. They should be knowledgeable. It means that they are aware of their situation and all variations of that. They should be organized for us. These are technologies, so whatever it takes to build these, this should be done. So our computer-based technology, if we go to this, we get application-independent information, which means that we are looking at shareability of our information, because the base technology says everybody understands these base fundamental values. And we're hardware independent because we're no longer dependent on the predefined hardware CPU instruction set. We go to a more generic technology, not an application of a CPU hardware instruction. And we remove all limitations, because if we get a integer technology that all integers can be represented, that we get rid of all of our limitations. Most of our, I'd say 90% of our errors right now are just simply the size of the integer. And change is possible. Right now we cannot change any of our applications, not realistically. Representing all types of integers, then we can change the number of bits dynamically in the same application, so we are not dependent upon a fixed number of bits. Oh, we set this 10 years ago to 16 bits, now we're at 32 bits, so it no longer works. And development time is reduced because we handle all the movement of information, the organization of information, the representation of the values, which is all we really do in software development. The logic is hardly anything. I would say our logic is only really about 1% once we handle. And then we can handle complex elements, like in a car. We could build engines, so we could build compilers and editors that are generic enough that we can use them in all of our applications. But for now, I'm just want to look at the base technology, not those compound. The thing is technology changes so fast, we have to get a handle on it so that change is handled for us and we can change it anytime by anybody. And we have shareable knowledge, which is really what we're looking for change sharing with ourselves. When we create a document or a form or a web page or anything, we can share that with all of our applications, so that we're not relying on these isolated applications, the billions of applications we have now. And then we have dynamic logic. The whole system is set up for change, and so we're not relying on, each user has a specific purpose for a document, and as that requirement changes, the logic can change. Oh, well, this is a book of 15,000 pages. That's a big difference between 2 pages, and the logic can change to handle that. So, and it should be a cumulative logic. This is the key here, is that over time we should be able to add new ways to represent an integer or a number or a fraction or a floating point or units or anything else. We need to be able to have 15 different ways to represent an integer. And if we wanted to add another one, we simply add it. It's flexible. This is really what I'm trying to get to, is it's like in software, it's like having an infinite number of hammers. We should not be writing software as a generic tool, not when software is so flexible. That's what I'm trying to say here. So it's like having a different engine in every car every day. My reality, it would be nice to just build one engine for every car out there, That way we're not versions of engines just to sell parts, which is what we're doing. And software should be much more for everybody.